Okay, so in this video I'm going to do another question which is similar to the ones with the trolleys and the F equals ma. And it looks different, but it's basically the same thing. So I'm going to do this and explain to you how this works. So first of all, it says two particles have masses of 20 kilograms and 5 kilograms. They're connected by a light, inextensible string that passes over a smooth fixed peg as shown in the diagram. So the two particles are released from rest. By forming two equations of motion, find the magnitude of the acceleration of the particles. Okay, so first thing I want to do is I want to put some forces on here. So there's going to be the force of gravity on this one acting downwards here, which is going to be 20g. And then there's also going to be the force of gravity on this one acting downwards, which is going to be 5g. Now, because there's a string there, the string is going to, the 20 is obviously going to be heavier, so it's going to accelerate downwards, whilst it's going to pull the 5 kilogram upwards. So the fact they're joined together by a string, there's going to be tension in the string, T, and because it's a light, inextensible string, the fact that it's inextensible basically means that the tension will be the same in both sides of the string. And then it's light, so it doesn't have any mass of its own, so we don't have to worry about any additional forces. So I can summarize the force situation like that. So there's a force of gravity on the 20 kilograms downwards and a force of T upwards from the rope. And then on the 5 kilogram one, there's a force of gravity downwards 5g, and there's the force, the tension from the string upwards as well. Now the system is going to accelerate, as it says, and it's going to accelerate this way, as the 20 kilograms is heavier, and this way. Now again, because it's held together by a light, inextensible string, that means that the acceleration on both sides of the system is going to be the same. So it's very similar to the situation with two little cars pulling one another. So in that case, the acceleration is the same and the tensions in the tow bar would be the same. So the situation is more or less the same, it just looks different, it's just presented in a different manner. But then the way that you solve it is similar, but we just need to look at the two particles separately and form equations for them, but again using F equals ma. So I'm going to label the two particles as number 1 and number 2. So we're going to do F equals ma. The question actually gives us a clue here. It says by forming two equations of motion. So we'll take that under advisement, and that's what we're going to do. So I'm going to do first of all for number 1. So I'm going to say that for this one, because the acceleration is going to be downwards and the force of gravity is going to be greater than the tension on this one, I'm going to use the downward direction as positive for this one. So down is going to be positive. So in this case then, 20g is going to be positive, and then I'm going to have minus t because that's going to be upwards. That is going to equal the mass times the acceleration, 20 times a. Okay, for number 2, so that's for the other one. Number 2, the acceleration is going to be upwards, so I'm going to use upwards as a positive direction. So in this case, t is going to be positive, and then 5g is going to be negative. And then this one is going to equal 5 times a. Again, the a is going to be positive because in the left-hand one, I did on number 1, I did it down as positive, so the a was down because the a is accelerating downwards. And in number 2, the a is upwards, and I did the positive direction as upwards, so that's why I've got my two equations like that. So I can now have those two equations, which I can label A and B. So those two equations have been formed by doing the physics by using F equals ma. So what I would need to do now is just to solve those two equations simultaneously. So it's said by forming two equations of motion to find the magnitude of the acceleration. So what it actually wants us to do is to find a. So the most simple way to do this then would be to eliminate t. So what I'm going to do is I'm going to add the two equations together. Okay, so if I do a plus b, so on the left-hand side, I'm going to have 20g minus t, and then plus t minus 5g. And on the right-hand side, I'm going to have 20a plus 5a. So just adding the two equations together. So I've got 20g minus t from the left from a, and then t minus 5g from b. So I put those together on the left-hand side, and then 20a and 5a together on the right-hand side. So now I'll see that my minus t and my plus t cancel out, which is fantastic. So on the left-hand side, I've got 15g is equal to 25a. And then I can then divide by 25, so I'll get a will equal 15g over 25, and then I can cancel those down by dividing both by 3, so I'd say it was the 3g over 5. If you wanted to, you could replace the g with 9.8 and then work that out as actually numerical. So I should also include meters per second squared. Okay, that should be the solution to that question. The question doesn't ask me to, but if it asked me for the tension in the string, what I would then do is go back and substitute in to work out t from the other situation. So in order to find t, I could then just substitute back into either equation 1 or equation 2 using my a, which I now know, and that would enable me to find t. All right, so I'm going to do another question as well. This one says a block of mass 12 kilograms lies on a horizontal surface. The block is attached to a particle of mass 18 kilograms by a light insensible string which passes over a smooth fixed peg. Initially, the block is held at rest, so the string supports the particle as shown in the diagram. Okay, so this situation is very similar to the one where the two masses were resting over the peg. Just this time, there's a block that's on a horizontal surface. So again, if I add the forces on, I'm going to have 18g down here, a tension in the string here. There's going to be a tension in the string here. There is going to be a force down there of gravity on the 12 kilogram block. But since the motion is going to be left to right, that force isn't going to be affected by it. So I'm going to leave that force out like that. So I'm just going to include the forces which are actually significant for this situation. Now, there is complications to sometimes these questions, and sometimes you get friction on there. There is actually more to this question. I've deleted it because it's beyond the scope of this video at the moment, but I will do a section on friction at some subsequent point, and then there'll be videos explaining how that works. So I'm just going to leave the forces like that for the time being. So part A says, assuming the surface is smooth, use two equations of motion to find the magnitude of the acceleration of the block and particle. Okay, so in much the same way as last time, we're going to have an acceleration that way. We're going to have an acceleration that way. So I'm going to have two situations 1 and 2. So I'm going to do part A. I'm going to say F is equal to MA. I'm going to do number 1 first. So I would just have T is equal to 12A. That's all there is to say about that one. For number 2, again, I can do the downward direction as positive because the acceleration is downwards. And so therefore, I would say that 18g minus t is equal to 18a, like that. Now I have my two equations. So it says, assuming the surface is smooth, use two equations of motion to find the magnitude of the acceleration. So again, I want to find the acceleration. So what I'm going to do is just substitute for the t in equation 2 by using what I had from equation 1. So I'm going to substitute into 2. So I'm going to get 18g minus 12a is equal to 18a. Then I can add the 12 to both sides, so I'm going to get 18g is 30a. So then a is going to be 18g over 30. And I can go through, divide that by 6, so I'm going to get 3g over 5. Okay, that would be fine for part A. So then part B says, in reality, the surface is rough and the acceleration of the block is 3 meters per second squared. Find the tension in the string. So for part B, if the surface is rough, it's told me the acceleration is 3 meters per second. So everything that happened in part A is now irrelevant. And for part B, I only actually need to look at this part here because it's told me what the acceleration is and I'm just looking for t. So I can just do just that bit. So for part B1, I can just have this block with mass 12, t that way, and the acceleration is 3 meters per second squared. So I would just do F equals ma, T is equal to 12 times 3, which would be 36 newtons. All right, so that question is reasonably straightforward there. There were more parts to it involving friction between the surface, but it's beyond the scope of what I'm talking about in this video. So I will come back and talk about the rest of that question at some other time.